Alrighty, Zach, did you think your last lesson was an easy one? Well, get ready for a hard one. And this is the way, it's just going to get more and more complex as we move through these lessons. The last one went over ratios and how to solve proportion problems. This one's going to go over advanced ratio problems at the end, but the first thing that we're going to go over is kind of a new concept, which is simple and I think kind of interesting, which is this trichotomy axiom. And then after that, we're going to go over negated inequalities. So a lot to go over, so I'm just going to jump right in, okay? So the trichotomy axiom, that's the first part. That starts on page 156, and it basically says this. Okay, this guy's name is Johnny. So Johnny writes a number on a piece of paper. Whatever, it could be any number. It doesn't even matter. Then he turns the paper over and he writes another number. Now, as far as the other number that he writes, there are exactly 3 possibilities and only 3 possibilities. When I say this out loud, this is going to seem very intuitive, but it's an important thing to know because it's going to help us with problems in the future. So the 3 possibilities are the second number he writes on the other sheet, on the back of the sheet of paper, it could be less than the first number. Okay? Obvious, easy. Number 2, the second number could be the same as the first number. The second number, this is the third one, the second number could be greater than the first number, okay? Those are the only possibilities. It's either going to be less than, it's going to be equal, or it's going to be greater than. And even though this seems super obvious, it's not trivial, meaning that it's not meaningless, it's not stupid, it's not, it's something actually important and profound. And when you realize that it can only be one of those things, you realize that all numbers have an order. There are an ordered set of numbers. And so because this idea has 3 parts, that's why it's called the trichotomy axiom. And what the heck happened to this word? Like, it looks like I shifted part of the, I'm going to rewrite it because I don't like that. My OCD is kicking in. Let's do trichotomy. Oh, heck. That's not helping my OCD. All right, let's try this. Trichotomy axiom. And tri means like a tricycle that has 3 wheels. In this situation, there are only 3 possibilities. And it says it in a little bit of a more mathematical way. For any 2 real numbers, A and B, okay, exactly one of the following is true, and only one, right? A is less than B, A could be equal to B, or A is greater than B. That is the trichotomy axiom. Okay, we're not done yet, so don't go anywhere yet, Baby Yoda. We are not done. The next part, we're going to go over negated inequalities, okay? And I'll explain what that means as we go through it. Now, symbols of inequality can be negated. That means like, what does it mean? It means like canceled or negative of it or the opposite of it, or like make it not true by drawing a slash through the symbol. So here we have, the way I've written it so far, I have x is greater than 10. But if I write a slash through this symbol, just kind of like that, then what that means is x is not greater than 10. And so when you negate something, it means that you add the word not. Okay, so x is not greater than 10. So now we go back and think about this trichotomy axiom. At first I said x is greater than 10, but if it's not, then it can only be 2 out of the 3 things. They could be equal, or x could be less than 10, right? So then if we see that x is not greater than 10, we have to say that x could be less than or equal to 10. And that's a result of the trichotomy axiom because it's going to be 2 of the other things, right? It can't be the third thing because we said not. And so it has to be one of the other things, but you have to include both possibilities because we don't know for sure which one it is. All we know is that it's not greater than 10. So here's the answer. If you have not A, it's X. If you have X is greater than 10 with a not sign through it, then that means that it has to be that X is less than or equal to 10. It has to be either less than or it has to be equal. Okay, so here's another example. In the same way, if we write X is not greater than or equal to 6, now in this situation, we already had 2 of the 3 axioms there. You had greater than and you had equals. So if we put a not through that, and if we say X is not greater than or equal to 6, then it must be true that X is less than 6, okay? All right, so on example 39.1, we're going to take that idea and we're going to go the next step, and when we get a solution, we're going to graph the solution. So the instructions say draw a number line, and then graph the solution of X is not less than 2. So X is not less than 2. So the first thing I'm going to do is take this X is not equal to 2 or not less than 2, and I'm going to turn it into what it has to be. If X is not equal to 2, then it must be true that X is greater than, whoops, I don't like that curve. I like the sharp. X is greater than, or what's the other possibility? It could also be equal to 2. And then this is the solution that we have to graph on the number line. Okay, now this is important because does it include the number 2 or do we leave it an open circle? And because there is this equal sign that is included, that means 2 is part of the solution because it could be true that X is equal to 2. And for that reason, I have to color it in, indicating that 2 is included in the answer. And then I draw my arrow, okay? And that is how we graph the solution to that. So the way that we read that is X is greater than or equal to 2. So the solid circle at the 2 means the number 2 is part of the solution. All right, let's do the next one. The next one is example 39.2. This is on page 157. And it says, write both an inequality and a negated inequality that describe this graph. All right, so the first thing that we're going to do is write the inequality because that's the easiest. That is just, what does this graph describe? Okay, so the graph says that here I see it starts at the 3 and it goes to the left, so anything less than 3 is included. So I'm going to write what I know so far. X has to be less than 3. And then I'm going to double check, is 3 included in that? In other words, do I need to add an equal sign right here? And since it's an open circle, 3 is not part of the answer to that, so I'm not going to add an equal sign. So the first inequality is X is less than 3, and that's what that graph is showing. Now, it also said to add a negated inequality, inequality that describes this graph. So what is X not equal to? So X, remember the trichotomy axiom, is not equal to 3. Whoops, oh heck. X is not equal to 3, and it's not equal to anything greater than 3. Okay, how do I know that? Because 3 is not included, and anything greater than 3 is not included. So I'm just going to write the answer as if it were that green line. So X is greater than or equal to 3, and then I'm going to say not. So X is not greater than or equal to 3. So that's one way to do it. You don't have to draw that second line. You can just look at it and say, Well, 3 is not included, and anything greater than 3 is not included. So just write that inequality. Or you don't even really need a graph. You can just look at this, right? And you can say, well, X is what's not included in this. And what I see not included, according to the trichotomy axiom, is that anything greater than 3 or equal to 3 would not be included. And then don't forget the not. That's the not. Okay, now on 39.C, this is on page 157, we're going to do advanced ratio problems. Now this is where you really need to pay attention. So if you're skipping ahead, I hope you at least see this little sign to yourself. Pay attention, this is super important. I put a picture of marbles here because it's going to talk about marbles soon, but you're also going to lose your marbles, meaning go nuts, trying to solve some of these problems because these are really, really hard. So some ratio problems are hard because there's important information that's sort of hidden in the way the problem is worded. Okay, so for example, in this example it says, if we are told that the ratio of red marbles to blue marbles is 5 to 7, we would write it like this, excuse me. Now, if we are told that we have a total of 156 marbles, that's our total number of marbles, and then you're asked for the number of marbles that are red, can you solve that problem? And it turns out you can solve that problem. It's just not totally easy or straightforward. So what they do is they give you 4 steps, a 4-step procedure that will make it easy. 4 steps, and it will be easy. Yeah, right. Easy as childbirth, right? Okay, so here we go. Step number 1 is you write the information given to include the total. And don't worry if this doesn't make sense at first, because we're going to go through it in examples and then it'll make more sense. Use the cover-up method. Remember the using your finger, whichever finger you think is appropriate, and cover up the piece of information that you're either not using right now or that is not important. And you write 3 equations, okay? And then you are going to reread the problem to determine which equation you need to use, and then substitute in the selected equation and solve the problem. I know, blah, blah, blah. What the heck are they talking about? So let's go through it in an example, and I think you'll totally understand it. Example 39.3 is basically the same problem as what they just gave us. The ratio of red marbles to blue marbles, so red to blue, let me use a different color, red to blue is going to be 5 to 7, okay? If there are 156 marbles in the bag, so we're going to say the total is 156 marbles. How many marbles are red? So now we have 2 pieces of information. The ratio of red to blue is 5 to 7, and they want to know how many marbles are red if the total is 156. Now, step 1 is to write what we know. They gave us a proportional ratio, and the first part of that proportional ratio is that there are 5 red marbles for every 7 blue marbles. Now let's say there are only 5 reds and only 7 blues. What would the total be? If that were true, the total would be 7 plus 5 or 12. I can't see that very well, so I'm going to write it in black. 7 plus 5, so 12. Okay, now that's a good piece of information for step 1. Now, step 2 is write all of the implied equations. So just like we were writing proportional equations before, we're going to do that with the information that we have. So the first thing, we have red, blue, and total over here. Red, blue, total. We're using the cover-up method. So the first thing we're going to cover up is red. And let's say we make a ratio, because you can only make a ratio with 2 numbers. let's say we make a ratio with blue to the total. Blue to the total is going to be 7. For every 7 blue marbles, the total is going to be 12. Okay, that's good to know. May or may not be useful. Now let's take our finger and cover up the blue. And let's make a ratio out of red in the total. For every red, how much is the total? So we know that for every 5 reds, there's going to be 12 total. It's just a ratio, but we've left out the blue marbles. Okay, now this last one. We're covering up the total, and so we're going to make a ratio out of red to blue. That's easy because that's what they gave us in the problem. The ratio of red to blue is 5 to 7. Now it says, reread the question. That's step 3, reread the question. And the question says that they give us a new total of 156. So they give us a new total of 156, and they want to know how many red marbles will we have. Okay, so now we know which equation to use. We go back and we look at these 3 possibilities with our cover-ups. And the variables that we're working with is red and total. So which one has red and total? It's obviously B, because there's red and there's total. So this is the proportion that we're going to use, the ratio we're going to use. So red over total was 5 over 12. So that's important, and that's going to be used in the problem. Now step 4 says, substitute 156 for the total and then solve for R. So now this goes back to a regular proportion problem that you've been doing all along. So the ratio of 5 to 12 is the same as the new ratio with a new total of 156, and red is the unknown. Okay? So now we're just going to cross multiply and cross multiply. And what I get when I cross multiply there is I would get 12 times R is equal to 156 times 5. And now it's an easy problem because you can just divide by 12, divide this by 12. This cancels out, and when it cancels out, your answer is going to be the number of red marbles is 156 times 5 divided by 12. And if you do the math on that, then the number of reds is going to be 65. Okay, and that's the answer. Alrighty, so it's a lot of steps, but that's what happens when they give you really complex ratio problems. Let's do another one to make sure that you've got it. Okay, so this is example 39.4, and it says, the ratio here of fish to crabs in the sea cave was 13 to 4. Now, if there were 119 fish, so this is like the new number of fish, so the new F, to crabs in the sea, how many, let's see, if there were 119 fish to crabs in the sea cave, oh, did you see that I did that? In the sea cave. All right, we'll just get rid of that. How many were fish? Did I write that? Oh, no, I did not write that right because it doesn't make sense. Okay, I must have been tired when I did this. All right, let's change this. Okay, it tells us that if there were 119 fish and crabs, so this is not the number of fish right here. This is the new total. So this is the total, the new total. Okay, and then it wants to know how many were fish. How many were fish? So it wants to know F and T. Okay, so, you know, I don't know if I need to, I would kind of write down in the new information that they give you, there's a new total, new T, and then it wants to know the unknown, which is the number of fish. So I would do fish, crabs, and totals, just like we did before, fish, crabs, and totals with the ratio that they gave us. But I don't know if I'd write down all 3. I would just use the one with the F and the T, right? So let's figure it out, but let's go through all the steps, okay? So A, we're going to do the finger method. So the first thing is to draw a finger, or let's just ignore this part of the equation. Doesn't let me. Let's just ignore this part of the equation, okay? And so what we're going to do is we're going to do C and T. You had to figure out the new total because all they did was give you a ratio of 13 fish for every 4 crabs. So you had to figure out this new total, and that's important because that's the first step, I think, is figure out the first total, okay? So then the number of, let's go to A. C over T is going to be what? And I'm just going to move this to the side, and I'm going to delete that. Okay, C over T is going to be 4, because that's the number of crabs, over the total, which is 17. Okay, so that's the first equation. Now, what about F over T? Now, instead of ignoring that information, we are ignoring the C. So we're left with F, which is 13, and the total, which is 17. Okay. If I were you, I'd probably just stop there because I know that this is the one that I'm going to use ultimately because the new information is they give you a new total and they want the unknown number of fish. But let's just go through the way they want us to. The third equation that it could be is if we ignore this new total and we have F and C, what would it be? It would be 13 for every 4 crabs. Okay, now we reread the problem and we figure out which equation out of the 3 we're going to use. So it says the ratio of fish to crabs in the sea was 13 to 4. Now there's a new total of 119 fish and crabs. That's the part that I messed up before. It's fish and crabs is the new total. And then it says how many are fish. Okay, so we're obviously going to use this equation right there because there's an F and because there's a T. Okay, Zach, so the equation that we're going to use is this one right here. F over T is equal to 13 over 17. Okay, so I'll write it like this. F over T is equal to 13 over 17. Now, to compare it to the new total, we're going to put the new total at the bottom here, which is 119. And then I'm going to put F on top because that's the unknown. And then this is the part of the equation that you solve just like anything else, okay? Just like we were doing before. All right, and the way that we're going to do it is we're going to cross multiply. So 17 times F is equal to 13 times 119. So I'm going to write that out. 17 times F is equal to 13 times 119. Then I divide by 17, divide this by 17. The 17s cancel out. So I'm left with F is equal to 13 times 119 divided by 17, which turns out to be, I just looked in the book, 91. Okay, so that means the number of fish, if the total is 119, it's going to be 91 fish. And that makes sense because there's way more fish than crabs. So if you have a total of 119, it makes sense that there's going to be 91 fish. All right, Zach, I'm going to let you go ahead and do your homework now. These are pretty tricky, so take your time and do it properly and try and get the right answers, okay? Good luck with your homework and have fun with it. Okay, bye.